So in question 17, we're given a pH. So pH equals 10.66, and now we want to know what is the H plus concentration. So that's going to be 10 to the minus pH is equal to H plus concentration. So in this case, that becomes 10 to the minus 10.66. And the answer I get there is 2.22 times 10 to the minus 11 is equal to H plus concentration. Okay, calculate the, question 18, calculate the pH of a 0.2 molar sodium acetate. So this is a salt that consists of, this part is the acetate anion, and it comes from acetic acid. When it ionizes, it forms that ion. So that's our equilibrium. CH3COO minus, in the presence of water, is in equilibrium with the acid, CH3COOH, plus, leaving behind, because it pulls a proton off water, OH minus. So first of all, we're going to calculate the pH, and that pH must be basic because this is a base. The other problem here is it gives us the Ka. It gives us the Ka for this process. So this is the conjugate base of that acid, and so we're going to use this relationship Ka multiplied by Kb, because this is a base reaction. We've got to have Kb in this equilibrium. That's equal to 1 times 10 to the minus 14th. So our Kb is going to be equal to 1 times 10 to the minus 14th divided by, in this case, 1.8 times 10 to the minus 5th. So then this becomes just a standard equilibrium calculation. So our initial concentration change and the equilibrium. Our initial concentration, we put that salt in water, and that's 0.200. That's 0, and that's 0. Our change is going to be minus x, and this is going to increase by x. So our equilibriums are 0.200 minus that x, and that's going to be x, and that's going to be x. So Kb, and I did that calculation up above, is, what did I get? I got 5.56 times 10 to the minus 10th, and that's equal to x squared over 0.200 minus x. But because that Kb is so small, it isn't hardly going to go to the right at all, and that is our approximation that's small. So this becomes 0.200 times 5.5 times 10 to the minus 10 is equal to x squared. So I'm going to take the square root of both sides to get my x, which, remember, my x is my OH minus concentration. Now I've run out of space here, so I've got to slide that in. The answer to that calculation is, so this is the OH minus concentration is equal to 1.05 times 10 to the minus 5th. And then I've got to do that same thing, H plus concentration times OH minus concentration is equal to KW, or 1 times 10 to the minus 4. Plug in my OH minus, solve for hydrogen, and then find the pH. So those still steps remain to do that I'm not going to do, but that's what has to be done.